Hey y'all. Alright, so today we're going to be talking about linked list, a data structure. And so my first video was the DFS video. And so if you've watched that video, I'm doing something a little bit different with the way I've formatted the notes and the theoretical walkthrough. I've added some more code in. I left the code completely separate in the DFS video. So just let me know how you guys like the format of these notes. And they'll be in the relevant GitHub repo with the lesson code. Okay. All right. So let's get started. All right. So a linked list stores a sequence of elements, right? And so these elements are stored in nodes, right? So linked list contains nodes which contain elements, right? And so these nodes, they contain the value of the element and a pointer to the next node in the sequence, right? If you don't know what a pointer is, it's a construct that holds a memory address, right? I'm gonna make videos on pointers and the way and memory functionality. It's very it's very fundamental in like systems programming and stuff. So if my video's up on pointers, go check it out. If not, do some self study on that one. So I have to call out. So I'm calling out here that they are not arrays, right? Because they can conceptually, like above the hood, they can, and to maybe someone that is used to arrays but not really linked list, you can vary. Like I've actually heard some people say, oh, why would I? Students and beginners say, oh, why would I use a linked list over an array? So conceptually, they're very similar when you think about them, right? Because arrays, they store memory in a row, but the thing about arrays is they store memory in contiguous memory locations, right? So every element in an array is going to be right next to each other in memory, right? Whereas in a linked list, you're using the memory allocation's arbitrary, right? Where the stuff is stored, and you're using pointers to just point to that memory address instead of it being right next to it, a neighbor in memory. You're telling a pointer directly where the address, you're pointing to the address in memory, right? We'll move on, but yeah, so that's the basics. That's the basic linked list versus arrays, right? We'll get into a little bit more later for use cases. Okay, so the actual linked list attributes, right? So they have dynamic sizing. They can grow or shrink at runtime, which makes them more flexible than arrays. You do have there is such a thing as resizable arrays, but that's a different thing. Okay. So arbitrary storage, this is basically just meaning that the nodes are stored, all over the place. They're not contiguous in memory like they are with arrays. And super fast insertion and deletion. Now this is why you use them, really, because the thing is that no matter how long your linked list gets, it's constant time, right? So the being able to grab the front or the back is instant, right? And so they're very good when the problem that you're solving involves some manner of queuing, right? Here's a little bit more discussion about linked list versus arrays, a little bit deeper. So you're going to use arrays when you need random access, right? Because arrays, how linked lists have that constant time at the tail and head, arrays have that everywhere. Completely random access, right? So if you got something stored at index 123, you just say my array square bracket 123, and there you go, man, you got it. So it's arrays are great at that. And also, when the data size is fixed or known, right? So like buffers, static configuration files, this is right. You can use buffers, you can use vectors or arrays has buffers, but say that you're there's usually special constructs for this, right? So like you've got like buff reader in Tokio, when you're doing async code. It's a specialized buffer where you're not having to manage and you're not having to manage like cursors and things like that. It takes care of all the buffer management for you. So old school, you can use arrays as buffers. And then cache optimization, right? So arrays have this attribute called locality of reference. You should go look up locality of reference. It's really it's based it's very important in in CPU architecture. There's temporal locality and there's spatial locality. Those are the two types. If you're interested, go look it up. I am going to have a video on it, but man, I will talk about it a little bit more in the code video. But I'm going to make a specialized video that will cover it. But if you're interested right now and there's no video up for me, go do some self-study. It's not vital to know it in detail to do this in the code, but you should know how it works, right? And so you use linked list when you have a lot of insertions or deletions, right? Like we talked about. So job queues and undo functionality, right? Because undo functionality, you just it's like, okay, that's basically like, okay, you're standing in line and you just got people coming up to you and you're like, no, not you. Then the next one comes up, no, not you. It's just a queue. You're just removing things from the head every time. So very easy. Also, linked lists have dynamic resizing and also the unknown variable data set. Here's some initial, like there's a big O notation, right? So we see that arrays have constant time when it comes to a random access. Linked lists have linear time, which means that it's based on the input, and then for insertion and deletion it's swapped. Okay, and then we've got some more facts here for you. All right, real world examples. So with arrays, you're going to have search engine indexing. Because they need fast, predictable access to large amounts of data, and then 2D graphic buffers, right? Man, you see, like there's lots of two-dimensional matrices, and there's a lot. When it comes, graphic buffers are very can be complex, and and they're efficient. So, and linked list for job scheduling, and those are the two big ones, man. Whenever you have a problem that requires any kind of queue or like a go back functionality, linked list is going to be your thing. Okay, so let's talk about the structure a little bit. So as we talked about it a little bit, a linked list consists of nodes, which contains elements, right? So a node contains the value of the element and then the pointer to the next node, or nil if it's the last node in the list. Okay, so this is the way that they look. So imagine this has a chunk of memory, right? So imagine this as a piece of memory. So we got 7, and then some functionality that calls the pointer to the next memory address. We get the next chunk of memory, and then we have next, which calls the next chunk of memory. And here is the last node, so it says nil, right? And then this is the code we're going to be using. Think of this as your node, and then this is empty, right? Empty/new, all right? Okay, and then I got a caption there. So you think of the container, right? So think of that as your node, storing the value and a pointer to the next node. Nil, okay, and then nil represents the end of the list. Now box is a Rust thing. It's used to assign heap. It's used to assign memory heap. It's used to assign heap allocated memory. Okay. If you don't know what a heap is, if you don't know what a stack is, I'm going to have videos on those as well. So check those out if they're up. If they're not, I'm going to talk about this in the code a bit, because this is actually kind of important to understand. So I do suggest, if you don't know how box works, look up a quick video, do a quick tutorial, and just kind of understand it, right? But I am going to go into how it works in the code implementation. Okay, so let's talk about the common operations, right? Because the way that I do these, I really focus on the core operations, right? And so these are the core operations we're going to implement. So for the core operations for a linked list are creating a new one, prepending a node, calculating the length, and reversal, right? So these are the 4 functionalities that I would expect someone to be able to do, like on an interview, or if I was giving a test or any kind of thing like that. Okay, so creating a new list, we're just calling a constructor and it's empty, right? Nil. And then prepending, you know, all we're doing is we're just, you know, prepending the node. You know, we'll get to it in the code. And so that's the code for it. Like I said, we'll talk about box. But yeah, so an empty one, a new or empty node contains nil. We call it prepend 7. That's going to assign 7 and nil because there's no other node. There's logic that handles that. And then if we prepend 5, well, it's not going to be the last node. So we're going to have 5, and we're going to get a memory chunk with 5, and then a pointer to our next chunk of memory. And then our next chunk of memory is going to contain 7 and nil because it's the last one. Okay, length. There's some recursion that takes place here. You'll see we don't need head because everything we need is in tail. And then if nil, obviously the length is 0. Okay, we're using some recursion here, some delayed return to get the total. If you don't know what recursion is, I'm going to make a video on it. It may be up, it may not be. I have a lot of videos to make. So yeah, but if not, there's a lot of this is really you can learn about recursion all over the place. It's a very fundamental topic in computer science. So good to know. And so, but we will talk about it a bit, and I will have some examples of what's happening in the recursion and the implementation. All right, and then reversing the list. Basically it's just traversing the list and rebuilding it. Right, that's all it's doing. And so we'll walk through the code. You can see here that what this does. This is not manipulating the list in place. This is creating a new list. Okay, and so we're creating a new list called rev. We're storing the current value. We're going to store the current value of the list in current, and then we're just going to destruct it. We're going to destructure it. We're going to just loop through this until we hit nil, and then we're going to return the new list, right? And we'll go through this in the code. And so the original list is going to look like this, and then the reverse list is going to look like this, all right? And remember, oops, don't want that. And remember, these are our chunks of memory, our nodes containing our elements. Okay, all right, guys, that's it. We're going to do the code implementation video. If you have any questions about this stuff, hit me up. Help each other out in the comments. Don't be an asshole. Ask respectable questions, and you will get respectable answers. And I'm going to see you in the next one. All right.